today, we're doing that quiz on 9.3. We're going to do that, a little bit of review of 9.3, and then we're going to do 9.4, which is the very last new thing we're covering before the exam. Today you have due Connect Math 9.1, 9.5, which we covered last class. Right, we covered last class and the class before. We did our quiz on it last class. Thursday, you have Connect Math 9.3 due, which is the quiz you're doing right now. And then Sunday, you have Connect Math 9.4 due, which is what we're learning today, because we have our exam on Monday. You can take the exam on Monday at 2 o'clock, 5 o'clock, or 7:30. If you prefer, you can take it Tuesday at 2 o'clock, 5 o'clock, or 7:30. If you take it on Monday, then you have Tuesday off. All right, so you have a longer one. If you're going to be gone that whole week, then I do have a few slots I can give people on Friday morning that you could take it in a different building though. So talk to me if you need to work that out. And then quiz chapters 7 through 9, those are reopened because remember in Connect Math, once the quiz is closed, you can't take it. So, so you can take those and you can do those until Sunday. Also, the exam wrapper 2 from exam 2 is due tomorrow. So that's the thing where you talk about how you prepared for the exam, what mistakes you made, what you want to change next time. So that's due tomorrow on Canvas. You can either upload a PDF or just type it in. And then there's 2 extra credits over the weekend, or over Thanksgiving, which is one is the what is a mathematician, right? About like all the different you can find a mathematician from any of the different backgrounds you want, or any of the different nationalities, or there's just so many different people, right? Mathematicians who come in a variety of people. So one on that one, and then another one on the soft skills. So the kind of 16 soft skills that are really important for students to learn while they're in college, and often, but they're not really academic. There are other types of skills and that you want to kind of work on, to kind of make your life more whole and kind of just be better at everything. They're good things. Like I think persistence, I think, is one of them. Right? So things like that are really good. All right, so that is that. Who's planning on taking it on Monday?
Like next Monday?
Yeah. Who's planning on taking it on Tuesday? Okay. And then also don't forget Monday, from 2 o'clock to probably about 7:30. Andrea will be in there, running some review sessions and stuff like that, or going over problems with people. Yeah.
So you have to can you come slightly at 2:15, or would you?
You can come at 2:15. It's a little bit tough because people will have already started, so you might lose a little bit of time.
Yeah.
Because I need to have it clear before the next group.
Yeah,
but yeah, and it is a full length like most of my exams are an hour and 50 minutes. This one really is a full 2 hour and 5 minute exam. So you're gonna need kind of the whole time to do it. So yeah, it's just a lot. Sorry. Sorry. All right. What's involved in experiment or survey? Remember, this, chapter 7, we did confidence intervals. All right. That's where if we don't know our proportion or our mean for the population, we can estimate it by taking a sample, and then we take a confidence interval around the sample. So we take a sample and find out, okay, yeah, we did a sample. The sample took us 40 minutes to get to Oakland Airport. But we're going to take a certain number of standard deviations before and after. So maybe it's 25 to 55 minutes, right? You kind of take this little interval around what you got. That's the confidence interval. Hypothesis test. If you happen to know the population mean, but you want to know if somehow your group differs from everybody else's. So then you do a hypothesis test to see if you differ, if your population differs somehow from the general population. That's chapter 8. And then chapter 9 is what we're working on now, which is when you have 2 samples that you're taking and you're comparing them to see if they differ from each other. So 9.3 is what we're working on now, the difference between two independent means. A couple things about them, they both have to be random samples. Two, they're independent of each other. That means you take a sample randomly and then take another sample randomly. The choice of the samples have nothing to do with each other. That's what makes them independent. And then of course, because it means that they have to have at least 30, or they should be no more distributed. All right. How do you find the test stat? Remember, we're assuming that the means are the same, so when you subtract them, you should get 0. It's just this part here. And we're using n minus 1 degrees of freedom, but we're using a smaller n. So for each of these, you're going to have an x bar, an s, and an n. So for your first group, you're going to have x bar 1, an s1, and an n1. For your second group, you're going to have an x bar 2, an s2, and an n2. And I highly recommend that you get in the habit of writing them out, like, kind of in a little table like x bar 1, s1, n1, x bar 2, n2, s2, or whatever. But you have them kind of in a spot where they're all together, because it just helps keep things kind of cleaner and easier. And whichever n is smaller, we're going to use that one minus 1 for the degrees of freedom, which is not that accurate, but that's what the book does, and it's close enough for what we're doing here. So quiz problem number 2. Francois is going to explain what he did for this one. Go ahead.
Well, the null hypothesis is mu is equal to mu2, and then h1 is mu is greater than mu2, and that's your claim, so we're going to support. The alpha is 0.1L, and the
Degrees of freedom
is 49, we're going to use 50.
Use 40. Drop down to 40, I think. Because there's in a 50, so you drop down to 40.
Oh, yes, they got down to 40. So it's 1.303, that's your critical value, and then for step 3, you do x bar or x1 minus x2, and divided by the square root of standard deviation of 1 to the square root divided by n.
The square divided by
Squared.
n, yeah.
Plus x2, x bar 2.
S2.
Or S2, that's right. Squared over 50, and you plug that all in, and you square root it, is equal to 1.029, and that is to the left of our critical value. So we're not going to reject H naught, and we're not going to evidence for the claim.
That
male offers are greater than female offers.
Right. So don't forget to say what the claim is at the end. Right. You can't just say support the claim stop, because if you stop there, then you will not get full credit. You're going to lose some points. Yeah. Oh, sorry. The other thing too is if you don't put it in the picture, like say he had not put this in, then I would say under step 4, I would have said why, and I would have subtracted a point on the exam because you didn't say why you're rejecting H naught. You have to have it in the picture clearly in the in that do not reject range. Good? Everybody understand what I'm saying? So that's what will happen if you don't do that. So make sure that you have this in here. Okay, great, thank you. All right, so now we're moving on to 9.4, dependent samples. So go ahead and put away your quiz, bust out your notes. So dependent samples are where what you pick for your second group depends upon what you picked for the first group. So what they are is they're matched up pairs. So here, for example, we have presidents and their opponents. So let's see if I can get better at this than I was last class. I couldn't remember any presidents. So for example, Trump was president and he beat Mrs. Clinton. Yeah, I couldn't remember her name. And then you've got Obama. I'm not really good with this here. And he beat Romney. Good, thank you. And then, so you had, I don't know who else. The first Clinton, who he beat?
It was Bush and Gore was the last.
Oh yeah, Bush and Gore, I remember that one. Bush beat Gore. And then, what was the other? First Clinton beat somebody. Oh yeah, McCain. Actually, he wasn't that bad. Right. We won a couple of them, right?
And I thought Obama beat McCain.
Who else?
It was Obama.
George
First
Washington
time, right?
and no.
I don't know. Close enough.
He won.
Wait. Actually, this is important. Did Obama beat Romney?
Yes.
Yeah.
He did?
Yeah.
Okay.
That's why you're
Okay. All right. So here's the thing. I have to match them up. And so I can't go Trump and Romney or Clinton and Gore. You know, everyone kind of follow what I'm saying?
Yeah.
They've got to be matched up with each other. Because what we do is, we do this. We subtract them. 189 minus 170, 19. 173 minus 85, negative 12. 8, 0, 1. So we find the difference between them and their partner. Does that, everyone kind of follow? So I couldn't do, if I did Trump and Romney, then it would kind of screw everything up, because they didn't run against each other. Everybody understand? So that's why these are dependent. The second group depends upon who I picked the first time. I can't pick someone the first time and then just pick whoever I want the second time and say, you know, oh yeah, Trump and, you know, Gore. That doesn't work. It's got to be, they've got to match up. So that's why this is a dependent one. Then this is super, super easy. So these are all my little D's, my little differences. Now, this becomes the easiest, really, of all the things in Chapter 9, this is by far the easiest, because all it is this one step, subtracting them, and then it's just a one sample t-test on the differences. So then all you care about, you can ignore all the stuff before, and now all you care about these guys. That's it. Put them in the calculator, use calc 1 bar stats to figure out the mean and standard deviation, and it's just a one sample t-test. Everybody are at that with that part? Good. So there's some notation at the top of your page. How about we get a reader? Alondra, good read for me.
Notation for dependent samples. D equals individual difference between the two values of a single matched pair. D not equals
Can you D?
D equals mean value of the differences. D for the population of all matched pairs of data. D bar equals mean value of the difference. D for the paired sample data. SD equals standard deviation of the differences. D for the paired sample data. N equals number of paired or sample data.
Right. So a couple things here. One is D bar. You can also get as X bar sub D. It's the same thing. You can call it either one you want. If you kind of that's sort of more consistent with the S sub D and the mu sub D, X bar sub D. That might make more sense. And then N is the number of pairs you have. Right. So after you subtract them, it's kind of the number, how many numbers you have left. Couple requirements. Obviously, the sample data are dependent. The first group you pick, though, those are simple random samples. So the first group that you pick, group 1, will be random, and then you kind of match up with whoever their partners are. And then, of course, obviously it's got to be normally distributed or at least 30 items in the sample. The test stat is pretty straightforward. Again, X bar sub D, you can put that in there, minus mu sub D divided by S over square root of N. So this is exactly the same as your yellow sheet. The one thing I would say actually is, since dependent is not on your yellow sheet, what you can do is in your yellow sheet, under test stat, hypothesis tests, the very top very top row, and then bust out your yellow sheet. It has your yellow sheet. If you don't use your yellow sheet in class, I'm going to take it away from you and you won't have it for the exam. So use it. And right here, on this one where it says, the very top one where it says t equals x bar minus mu over s divided by s over square root of n. Maybe next to that, under where it says h naught, I would draw the line below that one, kind of split it in half and put dependent, like DEP, mu d equals 0. So I would do that. I'd put in, let me see if I can find it. That would be really, really great if I could. Alright, so what I mean is right here, I would say maybe right here just put a little line and write in dependent, or you put depend if you think you're not going to remember that. Mu d equals 0. And then you use the exact same one. If mu d equals 0, that means that this, right, is that if that's your, whatever is in your claim, or whatever's in your h naught, is the number that goes into the mu naught. So, the great thing about this is, as we look at our problem, the cool thing about this is really, this guy is just 0, always. Because our claim is going to be that the difference is, we expect that the mean of the first one is the same as the mean of the second one, so the difference should be what? 0. So we're always going to assume that mu d is 0. Everybody on board with that part? Yeah. So it's even easier than a regular one because your mu d is, oh, you have to find it. You always it's going to be 0.
So it's just d bar over.
Yeah, it's just d bar over s divided by square root of n. Yeah. Yeah. Again, make sure you find the denominator separately because otherwise you're going to run into trouble if you do it without doing the two pieces, without doing the bottom separately. But yeah, it's actually easier in a lot of ways. Here's the confidence interval one, which again we're not going to cover, but I'm going to show it to you so that I've officially covered it. All right, so let's do an example together. Yes, you can. So if you want, you can cross out, oh dear, where'd they go? Oh, my bad, I should put it in here. So the confidence interval ones, because yeah, you all did this one, right, because it's smaller and then if you want, you can cross out this one, and you can cross out this one because we're not going to be using those. Totally fine. And you can cross out this one too, because we're not going to use that one either. Which I think we did already. Okay. Good. All right, so here's our example. So you should put the differences, if you haven't put the differences in here from earlier, you should make sure you write those into your table there. Right, you just subtract them, put them in there. That's sort of our pre-step. And then we're working just off of these guys here. So I'm going to put them into my calculator, my list 1. Right, I'm going to put them into list 1, and I'm going to find my x bar and my s. So I'll do that really quickly. Edit, and there it in there? 19, negative 12. Oh, hey, when you do negative 12, you cannot use the subtraction symbol. Remember, you gotta use this little negative sign next to the enter key. Don't forget that. That's for the negative 12. And then just pop them in here. Stat, put the zero matters, zero in there. Stat, calc, 1 bar stats, second L1, and then boom, you've got it. My X bar is 3.2. My SX, because remember which was a sample, is 11.4. I'm sorry? Yeah, L1 and then stat, calc, 1 bar stats. You'll notice that my X bar is smaller than my S. It's because my X bar, I expect my X bar to be 0. I expect there to be no difference. So, if that's supposed to be 0, then anything would be larger than that, really. Something else I was going to mention. Oh. Okay. And then step 1. Now I'm starting the actual steps. So step 1. My H naught, mu d equals 0. That's always going to be the case. Mu d equals 0. Now my claim was, so it's always going to be, this is always, when you wrote it in the sheet, didn't you under your hypothesis test, mu d equals 0? Someone have it right there, everyone see that? You all wrote that in there? So you show that that's what you are going to be using for your H naught. Now H1 is incorrect. H1 is, look back at the claim, it was that the differences have a mean greater than 0. So the differences, the mu d, should be greater than 0. That's my claim. Okay, next, step 2, let me find my critical value. So step 2 will be this is right tail greater than, and how many things do I have? I have 5, so it means my degrees of freedom is going to be 4, and my alpha is 0.05. So when I bust out my little t-table, alpha 0.05 one tail, I get 2.132, is that right?
Yeah.
2.132. Great. Positive 2.132. Next, I have my test stat. So that's going to be my x bar sub d minus 0. So I can just kind of ignore that really. Over s, which was
11.
thank you, 11 point. Oh, sorry, I should do this thing first. S over square root of n. And now I should write that in there. So it was 3.2, and I'm going to ignore the minus 0. Or you said 11.4 was it?
Yeah.
Over square root of 5. So this is pretty easy to find. I'm going to be lazy. Yeah, do you have the bottom?
Yeah,
Great. Awesome. Go ahead.
the bottom is 5.0.
And never hurts to have extra decimals along on the bottom if you like. And then we end up with 628, let's say. Great. The 628 is somewhere over here. I'll have my little notch here, but 6.628 is here. That's my test stat. Label, put it in there, label it. So step 4. Am I going to reject H naught or not reject H naught? Yes, do not. It's totally in the not enough evidence range, right? Do not. It's not unusual. Remember, reject when it's unusual. We reject if we get something unusual out here. So then step 5, we do, since we did not reject H naught, we do not have enough evidence. Yep. H1 was my claim, so I'm going to use the word to support claim that presidents, basically presidents are higher or taller than opponents. Okay, great. So you folks have problem number 4? Is it 4? 6? 6. Problem number 6 to do? Proceed.